Hi, Pratyush.
Hello, Mark. How are you?
I'm doing well. How are you doing?
I'm doing good. Thank you.
Good, good. Oh, and hello, Rudy.
Are we talking today test standards or CD? I can't really tell by the meeting invites. Are we talking materials or 3DKs? You know, Patush?
I would think MTK is done, so we could today we have both the invites. So I would assume it's test related. So let's see. David,
Yeah.
no, yeah,
All right.
it's
That's
confusing.
fine. All right. Yeah, I can't tell by the meeting invites anymore, right? I'd like it to be say test. So, yep.
Right. I thought this meeting was mostly going to alternate now between test and signal integrity. Is that right?
Morning, everyone.
Morning, David.
Hi, David.
David.
Let's see when we get the quorum here.
Yeah. Was there a question?
Yeah, I'll restate. The question is, this meeting kind of says MDK but I guess, are we talking MDK? Are we talking 3DKs? Or are we talking test standards or maybe signal integrity standards? I guess the invite says MDK, but I'm just wondering, David?
Yeah, there's actually a couple of invites. So let me give you the history. Right. Historically, CDX has been one meeting. Some time ago, when the 3DK work picked up, we created a separate CDX meeting specifically to tackle ADK and MDK, right? And that was and that meeting was at 9 a.m. With the idea that that's going to be a separate working meeting, work on those details. Once the proposals get published, we'll fold it back into the main CDX meeting.
Okay.
So so this is the main CDX meeting. Obviously, we can talk about anything we need to talk about. Right now, the two items that are ongoing in terms of work are the SIPI kit and the test design kit updates. These are kind of bi-weekly meetings and alternate. The ADK and MDK invites that were at 9 a.m. got moved to 10 a.m. We still can and actually do talk about those topics. The question is, what is next for us to actually do on the MDK side? Right, we published the proposed spec. Are there any updates that you guys do we need to make any updates?
Nope, just kind of querying there. So,
yep.
All right. Again, at Cadence, we have different DRIs depending on those topics. So, yeah. So I just want to make sure we have the right coverage. So.
Yeah. So Rudy, you know the link to the main CDX
I do.
page,
I'll have to
right?
go over there. Yeah.
Yeah.
I'll go over to that. Okay. That works.
Yeah. Yeah. I use that. Those are the main topics we cover. And we definitely would love to have folks from Cadence on the test side and the PISI side.
Okay. All right.
Okay, so I see a few more people have joined us. That's good. Okay, a couple of logistical items I wanted to ask you folks about. The first one is DAC is in June, and that is the week of the 23rd. I think at least for that week, I'm definitely will cancel the meeting, the CDX meeting, right? There is no, we're not going to be able to make it, right? I'm assuming a few folks will be busy with DAC and, right, I will cancel that. Now, my second actually question is, I will need to travel the first couple of weeks of June. So I am looking for volunteers to cover these weeks before DAC. So basically, the first one is the 2 or 3 weeks before DAC. So if you could please think about it, if you would like to help me out, I would definitely appreciate it. If I don't find volunteers, I will unfortunately have to cancel the meetings. And that is June, those meetings are June 5th, 12th, and 19th. Actually, 5th and 12th. That's 5th is SIPI, 12th is test. On the 19th, I may be able to make it. I don't know yet. So I guess once we get closer, I'll let you know. Okay. And then the third one is, are any of you going to DAC? Do you guys want to meet face to face? Sometimes we try to meet face to face, hang out and kind of talk about CDX or talk about, different topics of interest, kind of informal meetup. Is anybody going to DAC this year?
Normally, I do go to DAC. This year, I don't believe I will make it because there are a lot of other things happening during the same week that SI2 is involved with that I need to be covering.
Okay.
But I mean, it sounds like a great idea to have a meeting there.
Yeah. Are we going to be in the area, Mark, or not close at all?
Well, I mean, I live in the South Bay, so
Okay. Okay.
so I am in the area.
Okay. You were, yeah. Okay. My bad. Somehow, maybe because SI is on the is not on in the Bay Area, and I think my brain separates things, pretty binary. It's Bay Area and the rest of the world,
Okay.
which is far. So I mostly think people, like East Coast and that kind of thing, or something that is hours difference and something like that. So I was maybe because you're with SIT, I was under the impression you're not local, but that's good. Okay, so we'll figure something out then.
Okay.
How about anybody else going to DAC? Rudy, Pratyush, Vikas, Paula?
Yeah, currently no plan, David, but if it changes, I'll definitely meet up.
Okay.
Yeah.
Yeah. Do let other folks here in CDX know if your plans change and you will be at DAC, and we can always find a way to meet it. We don't have to plan it months in advance to meet up. If your plans change, let us know. We'll figure something out. Okay. So let's then switch a little bit gears and talk about test a little bit. Continue the discussion from last time. It was very interesting discussion last time. If I recall, Bala, you got some ideas that we were discussing some of your ideas last time. I was wondering, somehow I'm under the impression that you were going to prepare something.
Yeah.
And
So actually, yeah, last time I was actually totally the impression that I can utilize this CDXML as an application at the SIP testing. but Rajesh and others, they have corrected me, like where the CDX by itself, it's a chiplet component, right? So they were focusing mainly internal at the chiplet level, but I was kind of misleaded where I was sharing an idea of using this CDX at the chiplet level, what we can leverage for testing. And so possibly I need more time to put through some documentation and sync up with internally first within the Siemens teams, like SN
Yeah.
team and Tony, Pratyush, like so
Yeah.
to have some offline discussions before we get ready to for those proposals, because I feel that
Okay.
there's a value add, but that will be like a second step of the CDX. Like it won't be
Yeah.
CDXML specific, like into the chiplet.
Okay. Yeah. So the way CDX ML was meant to be is actually it has a couple of use cases. Definitely, it presents itself as it's a representation of a chiplet that the next level integrator can use that model together with other models and integrate chiplets together, right?
Right. Yeah.
But there is always this thing about, okay, CDXML does not really materialize at the very end of the flow, right? You kind of work in um how do I say, closed room, and all of a sudden a CDXML will pop out, right, at the end of the day. The way I'm thinking about it is CDXML, it makes sense to utilize CDXML across the chiplet development flow as well, right? At the very minimum, right, when you create when you have a chiplet, you have to create the bump map at the beginning, right? So that's where the one place where CDXML can be used, and throughout the flow, the bump map may change or pin assignments may change, and that's how at the end of the flow you get CDXML. So in that respect, and even in terms of even in terms of bump planning, right, there is at least two different bump map representations. One would be for wafer sort, where you have all the sacrificial paths and things like that, right? So that's one branch of the flow. The other one would be the integrator's view of the chiplet, where they're going to see the actual pillars and things like that, but not see the sacrificial paths. Right, so we already have that kind of duality in the CDXML, that there is a intermediate flow representation that may have everything, and once things get shipped out, we may have two different representations. Right, so now in terms of test, I do think it may be possible to have structures in CDXML to enable the test development of the chiplet itself. And then at the very end, once it's all test inserted and everything, whatever is relevant just to the chiplet implementation flow will get stripped out, and only the information which is relevant to the next level integration will get shipped to the end customer.
Yeah. Actually, yeah, I'm hearing you, like what you're saying, like where unless otherwise we tie this CDXML into the like a DFT development phases, like so there is not much of value add. Yes, most of the collaterals what is needed for the test development, which are predominantly derived from the DFT insertion collaterals. So we need to have some more deep dive discussions into that. Like because today The DFT development, like the DFT insertion flows are not sophisticatedly aligned for this IOs or the test pads, things like that, right? Because those libraries does not have test views kind of things where the CDXML can add some values there. So we might have to embrace in some more discussions with some technology development teams from some foundries like Intel or TSMC,
Yeah.
like where how these IO libraries are today. It has been generated and the people are manually integrating it in the RTL design or in the package design. So we need to have some automation synergy built into that areas.
Yes.
And so there are lots of things EDAs today does not have that capability, which are pushed back to the manual choice from the mainly from the RTL integrators. So there are many meetings which will happen between the architects, the functional architects, and the test architects to come up with these equations, right? What is the dependencies and all those things. So there are lots of potentials for the EDA companies to dive into this area
Yeah.
and automate that efforts. Like but yeah, let's see CDXML. Like I'm kind of getting biased to the 3D blocks initiative, like that they have more structured in place and they have design flows examples, things like that. So I wanted to see if we can leverage some of those techniques into the CDXML as well, right?
Yeah.
So that way there will CDXML, it won't be limited just as a spec, but it has to move into the design flows for the DFT insertion and the pad insertions and the guiding the test plan generation, all those aspects,
Yes.
right? So that
Yeah.
now
So,
all these three aspects are now it's manual. There is no automation in between these three worlds today.
Yeah.
so one thing, David and Bala, I'm thinking here, in an open chiplet economy, that's the purpose of this standards body to enable that. That's the overarching goal. You have the chiplet vendor providing chiplet along with all the integration guidelines within the package, along with all the test, whether it's the ATPG vector set or whatever test guidelines and test data set, right?
Mhm.
So all of those requirements, files and whatever formats they are, we need to probably add the in XML definition where those files will be, what all is needed for an independent ATE entity to test a chiplet coming from a third-party vendor. Right?
Yeah. So
Mhm.
so as far as file locations, um,
A specification, what is the file that is, yeah, whatever. Yeah.
right. So here's the thing, right? The IP exact, which is IP packaging standard, kind of deals with that stuff, right? It can describe the entire file structure of an IP, and by extension, probably of a chiplet, right? Where it tells you, hey, here's GDS, here's Liberty, here's test vector, here's UVM benches. It can describe a lot of stuff, right? And it tells you where the actual files are and what are the actual files. I'm generally kind of how do I say, I'm a little bit cool about adding file structure descriptions in CDXML, right? It's a good thing, but just pointing to files, I don't know, right? IP exact does it already, right? So,
I see. Okay.
right. I will need a little bit more reason, right? We probably should talk about that, whether how much value it adds or not. But what we overall, I think, would like to do is, those guidelines. If there's anything in PDF, we want to actually digitize that, right? If somebody has to go and read a PDF file and then manually input data somewhere, right, or make choices or specify pin names, we want to automate that process, right? I think in this day and age, it's fairly stupid to ask people to read PDF files and go and type things in a computer, right? That should be fully automated. So the question is, what are the contents of those guidelines that we can digitize, right? The first cut, version 1.0 of the test design kit merely dealt with identifying which pins are test pins and what modes do we have, right? And at least what I understand from the discussion with Tony was that kind of covers the early test planning and pin planning, right? Where you have your pin list and different test modes, and you're going to go and assign pins to different modes in a table kind of structure. You know, that's what the test instruction engineer will do. And we kind of wanted to automate that such that it's not an Excel spreadsheet. It's actually a file that a tool can then read. And second, that same information can be shipped out as part of the CDK, right? All the information that goes with the chiplet, we can ship a CDXML that says, hey, here's the test pins, and the test modes. Right? We stopped at the next level, identifying exactly what do those pins do, protocols and things like that, for two reasons. One, we didn't know what to do next. And second, really, we don't want to re-implement some of the other information that's available in already supported standards, right? Like patterns and and protocols and things like that, right? We cannot really define a new protocol. I guess we could.
So David,
but
actually, so what Pratyush was alluding to the fact that so you have a different number of pads, and we don't know from where the different models are sourced for those pads, right? So simulation tool consumes some Verilog models, and DFT insertion tools consume some like EKL or RDL representation of those models if there is anything existing. And also different EDA tools might have their own proprietary models to automate that process, right? So Tony's perspective was like we want to have EDA agnostic methods for these type of
yes,
models, right? Because users cannot build on all the models necessary for their tools, like a for insertion tool, for the simulations tool, and for the ATBG tools. So we have every tool has its own specific model and its own specific internal semantics of those models, right? And so those are the areas I think we need to have a dedicated work group with a technology development teams
yeah,
from the foundry. Like, so today, I think Intel is kind of started outsourcing all those technology development efforts to other companies, IP companies. So, but TSMC, they have their own, TSMC and Samsung, they have their own internal
yeah,
technology development companies, right? So if we have some quorum established with those type of people, I think that that's where all these requirements will come in. And
yeah,
so what you have mentioned, that IP exact, which the IP XML based flow, like that is a like proven methodology where but none of these technology development companies writes out the IP XMLs for all the different models, right? So they write out they write out a bunch of directories with based on the tools, Verilog model and ATPG model, things like
yeah.
that. And so it is the integrators like the functional RTL integrator and the DFT integrators. They go and identify and manually and then associate with a file list and supply to the different tools and build wrappers over wrapper scripts to manage those things, right?
Okay.
So Tony is like wanted to avoid all those things, manual efforts, want to build a sophisticated standard so that tools can come in, and so there has to be one central pointer to any tool based on its own needs. It should be able to dissect its own attribute and pick the appropriate model, right? So that portion of that equation is missing today in the CDXML. That's what
Okay.
Pratyush was referring, where on the 3D XML, for example, it has that 3D BV file, which has an attribute called external for each chiplet that points to the all the external files. Like, so it could be left or def or GDS or black box view. Like, so you can point, you can name it, right? So what are the different external files that 3D blocks needs it for each of the chiplet is sitting in the stack. So there it has an attribute. So if we provide such an attribute and call it for a different functionality like a simulation or ATPG or insertion like equal, like those type of things, we need to put it into the OCP, and we should also compare with IPXML in the IP exact model, like what they are giving it, and is there any correlation with that? Right, that
Okay.
way IPXML and CDXML can be interchangeably used for the file exchange across the tools. And so this will succeed only when the technology development teams, when they release the next level of PDK libraries, they need to give this such a wrapper file list, the IPXML or CDXML format, so that it can be seamlessly integrated with all the design flows. Okay, so yeah, let's discuss with like offline with Tony, and I can discuss with Tony and find out if we can have some collaboration established. Maybe or like other folks like Rudy, for example. Now there is a lots of momentum with Cadence and Intel. It's going on with the new CEO, because like a combined CEO, right? So if we can have some Rudy, if you can bring in some of your superpowers and bring, get.
He actually left.
Oh, he already left. Okay.
Yeah, he already left. But I'll ask him to listen to the recording.
Right.
No, I understand that. Yeah, okay. I think that makes sense.
Yeah, because without that, I think this is a quite a lot of manual effort today, like for the different users. Like, and I would imagine that that automation manual effort is going to be very humongous for the open chiplet economy, like where when the each sources are coming from the multiple different companies, and it is going to take months and weeks of just phone calls for the people to figure out just to put together common build, right, across the different tools.
Yeah. No, I agree with that. Yeah, we want to make the chiplet integration flows to be same as the way you would do it for an IP at chip level right now, right? It's pretty trivial to do it at the chip level, right? You can integrate 20 blocks fairly straightforward.
Yeah, even in chip level also, this problem statement is largely applicable. It's not only from the standard cells or the IO cells, IO pads libraries, but the things are scattered because the within the chiplet also they use different partition and different custom macros, and so there are lots of miscommunication happens. Like I have been dealing with those type of things when I was in Qualcomm, like so where I had to integrate just the memory based by consuming discussing with 13 different department, like that counts like 50 plus people. So like so every day like it's a significant bandwidth goes there, and to find out on the missing collaterals, and so there is lots and lots of things CDXML can penetrate into the chip design world as well, if we put together. And so and then also there are a few compiler dependent options like across the different EDA tools. like for example, simulation tools, for example, right?
Yeah.
Like a model sim from Siemens and VCS from Synopsys and NC sim from Cadence. All of them, they have a different user arguments for the same identical functionality across the tools, right?
Yeah.
So now today there are layers of make files and Perl scripts with a CAD team in a large companies. They maintain that and create a superset of functions which will internally identify the matching function across the EDA tools, right? So imagine if
Yeah.
OCP package guy needs to identify all those things manually, and he won't be able to done with that forever. Like so, like, with a given
Yeah.
1,000 die kind of a package requirement.
Yeah.
So yeah, I think that is not humanly doable.
Yes. So let me ask you the question like this. What can OCP help with in this situation, right? If it's foundries and EDA companies working together, how can OCP help in this process?
Yeah, so I think the first thing first is like we need to have a work group officially formed across the EDA, like to come up with an aligned cheat sheet, right, for the um, uh, how do we unify all this EDA agnostic solution, right? So
Yeah.
yes, people, um, um, this will be a moving target if we try to patch it right outside. Like, so EDA companies has to agree upon yeah solution and
Yes.
So
like
to put pressure on EDA companies for an agreed upon solution, would it make sense to start backward from the ATE vendor companies, what their testers need to run a test? That's the end problem we are solving through standardization here, right? When in a multi-chiplet vendor economy, multi-chiplet vendor economy. So would it make sense to look at what ATE tester needs, all the inputs, and we start backward?
okay, so
Because
ATE
DFT
tests.
tool should be, in the end, DFT tools are decoupled from tester at some stage, right?
Um, yes and no.
That's
Like
the goal of this.
just
That's the
the
goal of this exercise.
y-
That whatever DFT tool of choice you run to
mhm,
build your test infrastructure and generate your test vectors and test planning, it goes to the AT vendor, AT
right, right.
team, basically.
Mhm.
So all of that information needs to be kind of, we can agree upon a standardization there. I don't know what that means. You would know that, Bala, but
Okay, so okay, in terms of ATE deliverables, like it is there is only one standard, like where the what is the test pattern format, right? So that is predominantly on the style and then on the style to binary conversion. Then the ATE consumes that its internal binary language, right? So, but if you want to consolidate on the like a Yeti coverage and then associating all the binaries together and then coming up with a tool for the DPVM analysis and the yield 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 tracking. So that is totally different ballgame.
I
So
was having
for ATE,
feeling
just to
here
give
that we
you,
have discussed this before.
Sorry.
go ahead,
No,
Pratish,
no,
finish.
no worries, because I was just saying that I had a deja vu feeling that we have discussed this before. But it's immaterial. Okay, what were you saying, Vikas? Carry on.
Oh, I was saying like ATE, right now, see, most of the tests are structural tests. So they just need access to TAP, right? I think it's majority DFT problem, how to access those pins using a TAP or something like that. Like P-TAP, primary tap, secondary tap, and they run internally. Like so only thing what Bala is saying is correct. The format should be there. That's it. we do not need, I think, at this point of time, any um, like inputs from ATE, in my opinion.
Yeah, I think Pratyush is trying to add. There is another discussion for the TDK, right? So
Yeah, this is TDK discussion, test design kit, what all
yeah.
information do
So
you
here
have?
we are discussing mainly only that CDXML specific stuff, like what we can leverage and go into the design flows and in
I see.
yeah. So especially there are gaps around the test pads, the IO libraries, and what the stake from the DFT tools, right, for the insertion and then for the pattern generation, right? So that those things where we are predominantly focusing on today. Um, yeah, so I was focusing mainly onto that aspect, and then since you jumped upon and the ATE specific, I thought you are trying to bring in that
No, no, no,
TDK.
no. I was just thinking from like working backward from an ATE perspective, what all information an ATE needs
Uh-huh.
relating to a chiplet. Uh, so broadly, in the beginning, I said you need data files associated with your vectors, and there is a IP exchange. David alluded to. I did not know that. Thank you, David. So we don't need to do anything there. And the second one is guideline that David also talked about, right? There could be scope there to and what you were saying, Bala, in terms of every information that you need to collect from different teams, even at the chiplet level today,
Right,
that communication is not standardized.
right. Yeah.
Yeah, yeah. So there again, I was thinking to bring all the EDA companies together. Would it make sense to work backward from the ATE side and see what in the chiplet CDX definition, as well as in the TDK definition, we need to incorporate?
Mhm. Yeah, I mean, for this CDXML, I'm not
Mm.
very sure about the how much value add from the ATE perspective.
Okay.
So I was mainly going as a bottom-up thing, like we had to see
Mm.
what we can leverage within the DFT structure for the CDXML, and
Mm.
both in session and then for the follow-up for the pattern generation. Yes,
Mm.
um, even today, none of these EDA tools has provision to handle the test pads, right? There is no test pad view. Like so, people assume that the functional RTL or the functional architects they have a pre-planned and they instantiate those pads, and then the DFT will make connections to those pads as a data in, data out, right? Even
Mm.
all the other control signals, pad control signals to um, uh, also the transient control signals, things like that. So that has
Mm.
to be done outside the scope of the DFT today,
Mm.
right? So so that's where I was saying that so the CDXML can do a value add, so it can come up with
Yeah.
if we have an access to the test development folks, like so the people who are creating those different views for the test pads, and we can try and see if we can add the DFT insertion views and so make the DFT tools to handle it, right? So yes, at the end of the day, all the test pads are accessed and programmed through the JTAG, right? So we have all the tools uh, um, and methodologies to handle all the test specific needs to be integrated through the DFT insertion tools,
Yeah.
right? So that can potentially can be easily observed. It's a low hanging fruit for the any
Bala, do
DFT
you
EDA.
know what actually is your standard? What is the latest thing to do high-speed IOs testing?
Um, yeah, high speed IO testing. It is still there is no unified standard, right? So where each of
Right.
these FIs they are coming up with their own recommendation of the testing,
Hmm.
right? And
Okay.
so yeah, because now the bottleneck is like so you are not having a sufficient timing delays to accommodate to add some test structure, It's very highly congested and functional only driven, and so that's where we uh, even we are asking even UCIE committees, right, to drive and collaborate with the DFT needs upfront, because once they put it together, like UCIE, like for example, die to die, like it goes inside the package where you don't have an access from the tester directly, right? Unless otherwise you plan for the sacrificial pads. So
Okay,
right now,
this area, I think, yeah, that's what I thought. Like there is no standard or anything. So I just wanted to make sure, because this is one area majority of these chiplet will be lot of data transfer, high speed IO, DDR interface, and PCI Express and all those. So that's why I thought like I'll ask you what's your take on it.
right,
Yeah,
right.
so not UCIe. So take-wise, a lot of organizations, in fact, third party, because most verticals, typically Synopsys is a very big player there, right? And microcontrollers for PCIes and USBs. So so it's a very open secret in industry. So a lot of DDR-based schemes, USB-based schemes, people, I don't know if they have yet gone to PCIe interface to for scan in, scan out interface. That's what you're asking, Vikas, right? So
Yes, and
yes.
like what will how will the testing be done? Because if everybody has something different, or so standardization of that
So I
will be
would think
difficult.
I'll use the example of USB, right? And I haven't read the spec in a very long time now, but what I vaguely recall is there is a scope for like what you call the bare metal mode, right? You need certain things. Basically, the controller has to function without the software for the testing,
Yes,
right?
I'm
So
aware of that. Yes,
yeah,
I'm aware of
yeah.
that. Only thing is over here in this chiplet things, how will that happen? That's yeah. So you are right. I actually Intel also has this bare metal, and I think Boone is here. He can correct like LBIST and ACIO loopback and those things. Uh, so I think that's what you are referring. Like it has to
That's
work.
what yeah. So that's there. So for the chiplet, what additional we need to do is probably if you wanna include support for wafer level, right? Then we can, yeah. Then Bala, you make sense that UCIe interface there could be leveraged.
Okay. Okay, I need to read about it.
So maybe UCIe spec. I have 2.0 spec recently. Somebody shared with me a couple of days ago. Bala, I'll share that with you.
Yeah,
And
yeah, I did download that also last
oh,
week, I
you
think.
have it. Okay,
Yeah,
very
yeah,
good.
I downloaded. Yeah,
Yeah.
yeah.
So does it have a does it talk about the bare metal slash test mode?
No, I haven't got a chance to detailedly look at it. I just looked at like just the glance through it. Yeah, maybe we can do some homework and then we can
Yeah,
discuss
that's
about
really
that.
for
Yeah,
UCI consortia discussion. It doesn't
right.
belong here, but it needs to be there if it doesn't exist. Yeah.
Yeah, because to answer your question, right? So the people are mainly interested on three basic test features from any of the five,
Mhm.
right? So one is like leveraging the functional paths and then do a loopback testing, like internal and
Okay,
external loopback testing,
okay,
and then adding a LFSR and a BISER kind of structure in both sides, and create a random polynomial seed in one direction, and then drive that polynomial across the
got
pie,
it.
and
Understood.
then
Yeah.
observe through a miser signature on the other
Uh-huh.
side, right?
How
And
are
yeah,
debugs going in this one? How will you do debug? Does Miser signature will, like if we go in debug mode, will it open up and say that, oh, like this particular IO is not working?
yeah. So that will
Okay,
be
all right,
given for unique signature for each of the unique
got
lanes,
it. Okay, that's what I wanted to ask.
right? So
That
and
answers my
then
question.
there has to be a bypassing mechanism for each of the lanes,
Got it.
right? And
Okay,
so that bypassing you anyway needed for the to make use of the redundancy rules, right? So
understood.
as
Yeah.
long as you have unique way of decoding, like selecting and deselecting the targeted IOs. So you have a mechanism to find out which specific lane is broken.
Is this Bala documented somewhere? Do you have a document? I'm not aware of how.
No, but this is this is done by going through the experience only. Like you go through the CDX.
Okay.
Yeah, you look at the
Service.
CDX test plan. You look at the PCIe test plan. You look at the UCIe test plan. So
Got it.
find out like what are the different modes that they have, what paths that they are covering it, and so then you can make out the story. So, but at the end of the day, like all of these 3 test plans, I mean any 5 test plan, it will try to accommodate these 3 things basically.
Understood. Okay. No, that makes sense. Yeah. No, thank you so much.
Yeah, because people are not allowing you to add scan chains and to create more muxes.
Yep.
And so because excess kind of testing is already, it's not at speed test for the even within the chiplets, right, across the different partitions, because you are not covering end to end start and end points as mimic the functional timing paths.
Right. Okay.
Right. So because once you deviate from the functional timing path, and then people laugh at you and then say that, okay, no, I don't buy in this.
Yeah.
Right.
Okay.
So the high speed IO is more congested also, like because of this density. And so there's no room even from the right out of the spec to add some.
I mean, we are talking about suppose 1000 by 1000, and then stack is like 5. How many pins are we talking about over? Enormous number of pins.
Right. Yeah, that's the area at that critical locality is becoming a trade-off now for the test. Right. So that it means that you have to backward compatible with using the functional test.
Yes.
As much as possible.
Thank you.
Yeah.
Bala, are you aware of the IEEE working group on test? Abram Detovsky from Intel leads that effort.
Okay. No, I was not aware of that. So is it related to the OCP or it's just that IEEE guys?
It's IEEE thing. I think that is the group that in the end of the day defines different standards. Kind of it's like a work group. I'm wondering if that may be a good I haven't followed up what they are doing recently, but that's definitely one forum where all the EDAs and foundries go to talk about stuff, right?
Right. Yeah. Possibly we can join and be a listener, but what I hear from Tony is like he does not want to replicate what others are doing it.
Correct. Right? We definitely don't want to do that.
Yeah, in the OCP. So yeah. Let's see. Like I can also talk to Tony and then find out and who is driving it, and I believe somebody from Siemens also will be there.
Yeah.
And so we can consult with them and see if we can do something on that.
Yeah, the thing is, right, we definitely don't want to replicate, but also, this is a problem that's multifaceted, right? Definitely IEEE can set the standard for what the actual test does and how it does it and so on, right? We mentioned IP exact that does the file packaging. And then OCP carries information about chiplets, I mean, outside world view of chiplets, right? Which test methodology doesn't really, right? It concerns itself about the insides of the chiplets and how to run things versus, right, the external representation. So, there's room and probably need for different people to contribute to this, right? It's definitely not a one solution that can make it all happen. And I don't think even 3D blocks can be fully how do I say, support everything without overlapping with some of the other standards or even redefining some of the things, right?
Right, but the advantage with the 3D blocks is like they can extend lots of the key value has keys, right? because the model itself, it's not restricted. You can create lots of
Yes.
user attributes, and you can build the story like whatever the needs are. Like for each iOS, they have given a basic level of like a physical coordinates and orientations, and as a to start with a spec, but definitely when they will have lots of internal hooks with their automations, right?
Yeah.
And so they're not giving everything what they do, at least from the manufacturing TRCs kind of things. It's not written in the document today.
Yeah. Yeah. Okay, I see. Okay, so what do you guys think next step should be in terms of our work on test design kits? Where do we take this?
So yeah, one thing is like I can take an action item to articulate this the external file aspects, like for all the um, test IOs, like what are the different tools that we are interacting, and what we can write. I can come with a summary. What Pratyush was alluding that fact initially, um, and this that is one thing that is a value add for the CDXML that we can try to see if
Okay.
we can fit it into it. Um, and then the second thing is we need to see if we can discuss with technology development teams, like to create an IP XML for for their deliverables,
Yeah.
right? So
Okay.
if that IP XML is there, then the CD XML can be ported to that IP XML easily.
Yeah. Yeah. Okay. Yeah, let's do that. So maybe next time you can start us off with some proposal.
Yes. Yeah.
Okay. All right. Let's do that. Sounds good. I think that's a good plan. Let's see where we are and what's available and what we need to add.
So
And we'll go from there.
will that be in 1 week or 2, or like
2?
Okay, right, because next week is more about the signal integrity.
Yes.
Okay.
Yeah, we have this multi-personality right now. Tackling different topics. So yeah, it's bi-weekly. All right. Okay. Let's do that then next in 2 weeks. And see where we go. Next week then is SIPI.
Okay.
All right.
Sounds good. Okay. Yeah, thank
Yeah,
you.
any last comments before we close? I guess not.
No.
Okay.
not really.
All right. Okay, everyone. Then we'll talk again about test in 2 weeks then.
Thank you, David.
Okay.
Yeah.
All right. Yeah.
Okay. Yeah.
Have a
Thank you,
good one.
guys. Okay. Bye bye.
Yeah. Bye.
Bye.